Hello students, here is the 10th question of the exercise 1.1 and in this question we need to give the examples of a relation. So first question is a relation which is symmetric but neither reflexive nor transitive. So let us consider one of the set A and suppose which consists the elements 1, 2 and 3. So let us define a relation R1 on the set A. So we need to give an example of a relation which is not a reflexive. So not reflexive means we cannot insert the pairs 1 1, 2 2 and 3 3. So it means firstly I am going to insert here 1 2. So we need symmetric relation, that's why I need to use 2 1 also. And observe here 1 2 is exist and its reverse 2 1 is also exist, but 1 1 is not present here. So AB exists, BC exists, but AC is not exist here. So that's why this is not a transitive relation. Hence, R1 is a relation which is symmetric but neither reflexive nor transitive. I hope all of you understood this. Now the second question is, we need to give the example of a relation which is a transitive but neither reflexive nor symmetric. See here. Consider a relation R2 on the set A. So if I insert the pair 1, 2, so this is one of the example of a relation which is transitive but neither reflexive nor symmetric. Why? Because here the pair AB is exist but B is not related to any other element. So that's why this is one of the transitive relation. And observe here, this relation does not involve with 1, 1, 2, 2, 3, 3. So that's why this is not a reflexive relation. And also this relation 1, 2 is exist but 2, 1 is not exist here. So AB is exist but BA is not exist. That's why this is not a symmetric relation. Hence this R2 is a transitive relation but neither reflexive nor symmetric. I hope all of you understood. Now the third one, here we need to give the example of a relation which is reflexive and transitive but not symmetric. So for this consider a relation R3. Consider a relation R3. So we need a reflexive relation, that's why I need to use 1 1, 2 2 and 3 3. I hope all of you understood. And if I insert the pair 1 2 here, so this relation is not a symmetric. Why? Because its reverse 2 1 is not exist here. And one more thing observe here, for 1 1 2 2 3 3, all of these are pairs satisfies the definition of transitivity. And also 1 2, see here AB is exist but B is not related to any other. That's why this is one of the transitive relation. Hence, this relation R3 is reflexive and transitive but not symmetric. I hope all of you understood. Now, for the fourth one, we need a reflexive and a transitive relation but not symmetric relation. So, fourth one is similar to third one. So, I give a same here. R3 is equals to 1 1, 2 2, 3 3 and 1 2. So, this is one of the example for a reflexive relation and transitive relation but not symmetric relation. Now, the fifth one, see here the question we need an example of relation symmetric and transitive but not reflexive. So consider a relation R4. So we need a symmetric relation. So if I insert 1 2, I need to use 2 1 also. And also we need transitive relation 1 2 2 1 and we need 1 1 as well as 2 1 1 2. So that's why we need the pair 2 2 also. So now observe here, this relation is symmetric as well as transitive but not reflexive. Why? Because in this relation the pair 3 3 is not exist. So that's why this relation R4 is an example of a symmetric and transitive relation but not a reflexive relation. I hope all of you understood this question. Now let's start the next question. And the next question is, so in this question he has given one of the relation on the set A, and A consists of points in a plane, and the relation between P and Q is distance of the point P from the origin is same as distance of the point Q from the origin. So it means here the relation is R is equals to the points P and Q are related to each other only when OP is equals to OQ. So OP is the distance of the point P from the origin and OQ is the distance of the point Q from the origin. So this is what he has given in the relation. And we need to show that this relation is an equivalence relation. So observe here, let us consider one of the point in the set A, or you can write for all P belongs to the set A. We know that definitely OP is equals to itself. OP is equals to OP. If OP is equals to OP, P related to itself. So if P related to itself, this relation is one of the reflexive relation. R is what? Reflexive relation. I hope all of you understand it. Now for the symmetric relation, consider 2 points. For all P and Q belongs to the defined set A. Let us consider one of the pair PQ belongs to the relation R. If the pair PQ in R, from the definition of relationship, OP should be equal to OQ. This can also be expressed as OQ is equals to OP. When PQ in R, OP is equals to OQ. If OQ is equals to OP, definitely the pair QP belongs to relation R. Since PQ in R as well as QP in R, it means this relation R is one of the symmetric relation, which implies R is a symmetric relation. R is a symmetric relation. Now for the transitive relation, consider 3 points. For all P, Q, R belongs to the set A. And let us consider two pairs. Let PQ belongs to the R and the pair QR belongs to the relation R, which implies from the definition of relation OP is equals to OQ, and if QR belongs to R, OQ is equals to OR. So observe here, OP is equals to OQ and OQ is equals to OR. It means OP is equals to OR. So which implies the pair PR belongs to the relation R. Since PQ belongs to R, QR belongs to R, and hence PR belongs to R, which implies this relation R is a transitive relation. R is a transitive relation. Since R is reflexive relation, symmetric relation, and transitive relation, hence relation R is an equivalence relation. Is an equivalence relation. I hope all of you understood this. Now let's start the next question. And the next question is, so in this question also he has to given one of the relation on the set A, and A is a set of all triangles, and the relation between T1 and T2 is T1 is similar to T2, and we need to show that this relation R is one of the equivalence relation. So if the triangle T1 is similar to T2, then only the pair T1 T2 is in this relation R. And similar triangles means if suppose this is the first triangle T1 and this one is the second triangle T2, and A, B, C are the sides of the first triangle and D, E, F are the sides of the second triangle. These two triangles are similar if A by D is equals to B by E is equals to C by F. If the corresponding sides of the both the triangles are in same proportional, then we call that two triangles are similar. Or in other words, two triangles are said to be similar if they have same shape but different size. And also we call that every triangle is similar to itself. So if suppose same figure nu ಇಲ್ಲಿ draw ಮಾಡಿದ್ನಪ್ಪ ಅಂದ್ರ T1, then their sides also A, B, C. So A by A is 1, B by B is 1, C by C is 1. So it means every triangles are similar to itself. Now see here, to show that this relation R is one of the equivalence relation, so we need to show that relation R is reflexive, symmetric, and as well as transitive. So as you know that every triangles are similar to itself, it means definitely this relation is one of the reflexive relation. See here, for all T belongs to the defined set A. Since T is similar to T, this is a symbol of similar, which implies the pair TT belongs to the relation R. So which implies the given relation R is one of the reflexive relation. One of the reflexive relation. I hope all of you understanding. Now for the symmetric relation, consider two triangles. For all T1, T2 belongs to the defined set A. Let us consider a pair T1 T2 belongs to the relation R, which implies definitely T1 is similar to T2. Or in other words, we may say that T2 is similar to T1. If T2 is similar to T1, definitely the pair T2 T1 belongs to the relation R. Since T1 T2 belongs to R and T2 T1 belongs to R, which implies the relation R is one of the symmetric relation. Is one of the symmetric relation. Now for the transitive relation, consider three triangles for all T1, T2, T3 belongs to the defined set A. Consider two pairs. Let the pair T1, T2 belongs to relation R and T2, T3 belongs to the relation R. So if T1, T2 belongs to relation R, definitely T1 is similar to T2 and T2, T3 belongs to R, it means T2 is similar to T3. And see here, T1 similar to T2, T2 similar to T3, it means T1 similar to T3. If T1 similar to T3, definitely the pair T1, T3 belongs to the relation R. So which implies the relation R is one of the transitive relation. Is one of the transitive relation. So since the relation R is reflexive, symmetric and transitive, hence the given relation R is one of the equivalence relation. R is one equivalence relation. I hope all of you understood this, and this question is important for 3 marks, one time asked in your annual examination. Let's start the next question. And the next question is, in this question also he has to given one of the relation R on the set A, and A is a set of all polygons. Polygons means closed figure involves with 3 or more than 3 straight sides. For example, triangles, rhombus, or pentagon, or hexagon. So these are all called as what? Polygons. Poly in the sense many. Poly means what? Many. Gons means sides. So the polygons means closed figures having 3 or more than 3 straight sides. It is a closed figure. First thing, it is a closed figure having 3 or more than 3 straight sides. We call it as what? Polygons. And this relation R is defined on the set of polygons, and the relation between P1 and P2 is P1 and P2 have the same number of sides. If both the polygons P1 and P2 have the same number of sides, then only P1 and P2 are related to each other. And we need to prove that this relation R is one of the equivalence relation. So here to prove that this relation R is one of the equivalence relation, first we need to prove that it is a reflexive relation. So first thing, the given relation R is the pair P1 and P2 is in R only when number of sides of the polygon P1 is equals to number of sides of the polygon P2. So this is what he has given here. This is what one of the relation defined on the set A, and A is a set of polygons. Now for proving this is a reflexive relation, so for all polygon P belongs to set A, and we know that number of sides in the polygon P should be equal to number of sides in the polygon P. It means the pair P belongs to this relation R. So which implies the relation R is one of the reflexive relation. One of the reflexive relation. I hope all of you understanding. Now for the symmetric relation, for all P1, P2 belongs to the set A. Let us consider a pair P1, P2 belongs to the relation R. So if the pair P1, P2 in R, definitely number of polygons in the number of sides in the polygon P1 is equals to number of sides in the polygon P2. Or we may call it as number of sides in the polygon P2 is equals to number of sides in the polygon P1, which implies P2, P1 are related. P2, P1 are related. Since P1, P2 belongs to R and P2, P1 belongs to R, which implies the relation R is a symmetric relation. Which implies R is a symmetric relation. Now for the transitive relation, consider 3 polygons. Suppose for all P1, P2 and P3 belongs to the defined set A. So let us consider two pairs. P1, P2 belongs to relation R and P2, P3 belongs to the relation R. See here, if the pair P1, P2 belongs to relation R, it means number of sides in the polygon P1 should be equal to number of sides in the polygon P2. And P2, P3 belongs to R means number of sides in the polygon P2 is equals to number of sides in the polygon P3. See here, number of sides in the polygon P1 is equals to number of sides in the polygon P2, and also number of sides in the polygon P2 is equals to number of sides in the polygon P3. It means number of sides in the polygon P1 is equals to number of sides in the polygon P3. So which implies the pair P1, P3 belongs to relation R. So hence this relation R is one of the transitive relation. One of the transitive relation. Why? Because P1, P2 belongs to R, P2, P3 belongs to R, as well as P1, P3 belongs to the relation R. That's why this is one of the transitive relation. Since this relation R is a reflexive relation and symmetric relation as well as a transitive relation, which implies this given relation R is an equivalence relation, is one of the equivalence relation. I hope all of you understood this question. Now let's start the next question. And the next question is, here also he has to given one of the relation R, and this relation R is defined on the set L. L be the set of all lines in the xy plane. So L is one of the set of all the lines in the plane xy. And the relation between L1 and L2 is L1 is parallel to L2. And we need to prove that this relation R is one of the equivalence relation. See here, in this question he has to given one of the relation R on the set of lines where the relation is L1 and L2 are related to each other if and only if L1 is parallel to L2. And we need to prove that this relation R is one of the equivalence relation. So first, for proving this relation is one of the reflexive relation, for all L belongs to set of the lines L, and we know that every line is parallel to itself. So it means L is parallel to L. If L is parallel to L, definitely the pair LL belongs to the relation R. So which implies the given relation R is one of the reflexive relation. Is one of the reflexive relation. Now for the symmetric relation, consider two lines for R. L1, L2 belongs to set of lines, and let us consider a pair L1, L2 belongs to the relation R. So which implies definitely L1 is parallel to L2. See here, if this is a line L1 and this is a line L2, if L1 is parallel to L2, definitely L2 is parallel to L1. So which implies what? L2 is parallel to L1. Since L2 is parallel to L1, it means the pair L2, L1 belongs to the relation R. Since the pair L1, L2 belongs to R as well as L2, L1 belongs to R, which implies this relation R is one of the symmetric relation. Is one of the symmetric relation. I hope all of you understanding. Now for the transitive relation, consider three lines L1, L2, L3 belongs to set of lines. See here, suppose this is a L1, L2 and this one is a L3 line which is parallel to L2. Observe here, L1 is parallel to L2 and L2 is parallel to L3, and hence definitely this L1 is parallel to L3. Obviously, see here, let us consider a pairs L1, L2 belongs to the relation R and L2, L3 belongs to the relation R, which implies L1 is parallel to L2 and for this L2 is parallel to L3. So we can also be written as L1 is parallel to L2, L2 is parallel to L3. So which implies L1 is parallel to L3. So which implies the pair L1, L3 belongs to this relation R. Since the pair L1, L2 belongs to R and L2, L3 belongs to R as well as L1, L3 belongs to R, which implies this given relation R is one of the transitive relation. One of the transitive relation. Since this relation is reflexive, symmetric as well as transitive, it means this given relation R is one of the equivalence relation. Equivalence relation. I hope all of you understood this question, and this question is important for 3 marks, many times asked in your annual examination.